What's up YouTube? Today we are going to create a simple snake game in ReScript. I hope in this video you'll be able to see more examples of how to write your own ReScript bindings and get a feel on how to code in ReScript. First, let's use create ReScript app to create our basic template. We're not going to use React today, so we'll opt for the basic one. And of course, we always want ReScript core standard library. Today, I'm going to use Visual Studio Code, and I have installed the ReScript Visual Studio Code extension, so you can see how it performs here. First, we'll change a couple of things. I am using pnpm, so I'm going to remove package.lock.json. I also want to install esbuild. I will also install ReScript next. As you can see, at this point in time, we have ReScript 11 with release candidate 5. I also don't like to not pin my dependencies, so I'm going to make this as exact. Run pnpm, install again. And then I'm going to write some script here to have esbuild run and serve my code for development purpose. I'm also going to rename the bsconfig.json into rescript.json. This is just a convention going forward by the ReScript team. I'm going to change this into ES6. I'm going to create a public /index.html. All of this code here just to make sure that whenever there's change in our code, then esbuild will reload this index.html. Let's change this to app.res. And let's run the ReScript build. On another terminal, let's run the esbuild. Let's see if we are able to build this correctly. Okay, it looks like it says failed to load resource. The server responded with app bsmjs not found. I think I know. This one should be .js. Okay, so it seems that we have our hello world. Let's try to change this. Hello YouTube. There you go. We have our development server. Okay, so we are going to work with the DOM directly. So we are going to create our own bindings. There are a lot of third-party ReScript bindings that you can find online, but I find that it's easier to just write your own because it's easy and you can learn something along the way. So that's what we're going to do today. We will need document.getElementByteID. We also need document.addEventListener. We also need window.requestAnimationFrame. We will also need canvas.getContext because we're going to use canvas today. Canvas.clearRect. Actually, this is context. Context.fillRect. And then context.fillStyle. So let's see how we can create all these bindings. For document.getElementById, we can just use the @val and scope. This one will receive string because that's the ID, and it will return a canvas or null. So let's just return nothing for now, and we'll come back to this later. Let's create a canvas module. So canvas will have a type t, and this will return the canvas.typet. Actually, this can return null as well, And we want to be able to capture that in ReScript. We can create our own tag union. We want this to be unboxed. If you don't know what this means, please refer to my previous video. So now we can use null.t. Next, we're going to create the document.addEventListener. It's going to be mostly the same thing, so I'm just going to copy this. The difference is addEventListener will receive an event type. This can be key down, key up, but I only care about key down. So let's create the type here. And I'm going to use it here. Next, it will need a callback, and the callback will have some event type that it receives and returns nothing. Let's create the event. Module event type T. So we can use it here. The type T here actually will have field called which, and this will have some number type because depending on which key you hit on the keyboard, the number will be different. So I'm going to create another type here. I will name it arrow type. Arrow key. 37 will be left arrow key. 39 until 40. So this will be left, up, right, and down. Let's create the window request animation frame now. So it will be the same thing, but I will change the scope to window. Window request animation frame just requires a callback to be called. This callback will receive nothing and returns nothing. Alright, now let's take care of the canvas.getContext. So canvas.getContext, it requires send attribute, and it will return the context type. So I will just write context.t here, and then create a context module here. So the type T here actually will have width, int, height, int. Because canvas has these two attributes, width and height, that we will need. And the context actually will be either 2D or something else, but we only need 2D. So I will just use the 2D context. Now let's take care of the context.clearRec, fillRec, and fillStyle. We need to have a type T. For the clearRec, we need the send attribute. It will receive the T, and then X as int, coordinate Y as int, width as int, height as int. You can see here that I'm using a name parameters so that I don't get confused because everything seems to have of type int. I'm going to create the same for fillRec. And for the context.fillStyle, because this is a setter, we need to use the set attribute. And the string here will be hex code color, returns nothing. There you go, we have our bindings. Now let's create some constants file. I'll just name it settings file. I already know what I want, so I'm just going to paste it here. So this refers to pixel. I am going to have 16 pixels per grid, and this is just to slow down the frame rate. And board ID here refers to the index.html canvas ID, and foot color and snake color is just the color of foot and snake. Let's create another file for utils. I already know what I want here, so this is just an util to get some random integer. Okay, so let's create the foot file. The food here will have type t. It will have the coordinate, x coordinate, and y coordinate. Let's create a function to make the food. And I'm going to have the min here 0, max 25. The reason is because I have the canvas here as 400 pixels. And I want to have 16 pixels per grid. So 400 divided by 16 is 25. So I want to put the food somewhere between coordinate 0 to coordinate 25 on both directions. As you can see here that the VS Code gives us a nice autocomplete. And then I'm going to create two functions to get the x and y coordinate. Why don't just access the x and y directly? Because I am going to actually close this module so that x and y is not accessible directly. I think this is just a good practice because we realize that food.x and food.y is actually just an implementation detail. So let's create food.resi file. And in here, we just say type t, let make, returns type t, let get x, receives t and returns int, let get y, receives t, and return int. So from the user of this food module right here, the user just needs to know that the food.res has type t, has a make function that returns a type t, and has a get x function that receives type t but return an int, and has get y function that receives type t and return an int. That's all that it needs to know. It doesn't need to know how does it get the int from the t and whatever the actual type of the t here. It doesn't need to know at all. So we have our food, so let's create our snake. The snake type will have an x coordinate, y coordinate, x velocity. So this refers to how fast the snake moves in x direction, and y velocity. And it also has cells. It is an array of cells. And it has max cells. Let's create the module cell. The cell here just has x int and y int. And let's create a make function. Let's create a make function for snake. I want it to be on coordinate 160 for x and y. And I want to have the velocity, which is the pixel here that we have on x direction. And for the y, I want to have it 0. At first, the snake doesn't have any cells. And we have the max default of cells as 4. Let's create some functions to modify the snake state here. First, I know that I will need the snake direction. I also know that I will need the function to modify the snake speed. Alright, that's all for now. So let's create the snake.resi file. Nothing too surprising. Now let's create the board file. The board will have type t, and it will get the context. Before that, let me just alias all the bindings here. Let's create a make function. And we know that it needs a canvas. And canvas has a function called getContext that receives the canvas and use the 2D parameter. So it get the context, and we can save the context here. And we'll have a function to get width. Let's create a function to clear the board. I want to destructure the board here. And then I'm going to use clear rectangle. Let's create a function to draw the food. I'm going to get the context from the board. And we are going to set the fill color. And also we are going to fill it. Let's create a variable here called rectangle size. This will be settings.grid -1. We found a bug for you. Value fill rectangle cannot be found. I forgot to put context here. There you go. Okay, now let's draw the snake. So how do we draw the snake? When we draw the snake, we want to access the snake cells, right? And we draw the snake cells one by one. I'm not going to open up the snake.cells to be accessed by board because the snake.cells is an implementation detail. So instead, I'm going to have a function called iterate cells that the snake has. Within that function, the user needs to pass a callback, and this callback will receive the cell. And we can do whatever we want with the cell. So something like this. We have the same thing as the draw food. First, we are going to set the color. And we will have a function called snake dot maybe iterate cells. And in this iterate cells, it will need to be passed a callback function that will pass the x and y coordinate. So we can draw the x and y coordinate just like we draw the food. And obviously this one fails because we don't have a function called snake.iterate cells. So we're going to write it now. If we write the resi file first, it will look like this. Now we're going to write the actual implementation. So we're just going to use array for each on snake.cells. And we have the cell here. And we just call the callback with cell.x and cell.y. The compiler doesn't complain anymore. Okay, now we have a really basic functionality. Let's see if we can render the snake and the food on the board right here on the right. So let's go back to app.res and we are going to get the canvas, get element by ID, settings port ID, and we switch the canvas. If it's null, then we just console log cannot find element with ID, settings port ID. If it's not null, that means the canvas is present. So we are going to make the board. We are going to make the snake as well. Let's make some snake here. Let's make some food. And let's see if we can draw it. Board dot like here and board dot draw snake. Oops, this is not snake.food, snake.make. Draw food does not belong to... I need to pass the board here. Here it is. Okay, draw food. Okay, let's create the board.resi file first. just to make sure that we have the correct type. Let's try again. Board, draw food. We'll get board and food. Ah, this one here. I feel dumb. Alright, so we can draw our food here. As you can see, the yellow here, that's the food. If we refresh this, then we can see that the food will be located in a different coordinate because we use the random numbers. So what about the snake? Right, so we don't have anything here because the snake cells is empty. So for testing, let's just make some cell here. Maybe 100, 100. Okay, we have our snake. So we verify that we're able to render food and snake on the board. I'm going to return this to empty cells. Done. So what are we going to do now? We are going to create the game logic. Let's create the game.res file. So the game logic here will basically be just a function that loops, and the request animation frame will recursively call that function. Let's create the function, recursive function loop, that receives nothing and returns nothing. And we want to call the bindings.request animation frame and pass this function right away. First, we will need to do something with the snake here, right? We need snake. We also need the food. We also probably need the board. So how can we pass it to the function here? Instead, we're going to create another function on top that wraps this loop function, and that wrapper function will return this loop function. Basically, we're going to use the wrapper function to create a closure over snake, food, and board. Let's do that. And we just return the loop function here. And I'm actually going to change the snake and the food state. So we want this to be a reference. So let's name that so that we don't get confused. Let's see how we can use this function in the app.res. And I mentioned that I want this to be a ref. So this is how we're going to use the loop function. Let's verify that this loop function actually runs. I'm just going to console log stuff here. So you can see here that we can verify that the game loop runs. Okay, so let's code the logic. Let's think what we need to code here. So obviously you want to move the snake. And we check if snake eats food. Check if snake eats self. And maybe we'll do render snake, render, right? So that's all we need to do. Let's code the function to move a snake. Imagine we have a snake move function, and this receives the snake. Actually, let me just make sure that we are using the right one here. So we're going to move the snake, and we are going to replace the snake ref with the new snake that has different coordinate because we just moved the snake. And if snake eat food, we need the snake and food, then we do something. Else if snake eat self, we do another thing. And then we want to do board.clear because we're going to clear everything and we're going to render the snake. So now we're just going to code something here. If snake eats food, then we want to increase max cells. And we are going to respawn. If snakes itself, then we're going to respawn That's pretty easy. So increase max cells, we already have the function for that. Respawn the food, we also already have a function for that. So we do the same thing here. So now we just have to make the snake dot move. It will receive the snake type and returns the snake type. Let's go to the implementation. The new x coordinate should be snake.x plus snake.dx. And the new y coordinate should be snake.y plus snake.dy. We need to remember that the snake can go over the board, so we want to wrap it around. So let's create a function to wrap it. I'll name it wrapx. We want it to wrap, and we need the board width. And we will also need to wrap it here. This one will need the board height. And we'll return the new snake with x equals to new x, y equals to new y, cells equals to new cells, because we need to actually extend the cells. Let's create a function to extend cells that receives new x, new y, and snake max cells. So let's create all of these helper functions. Before that, I need to pass the port width here. So let's create all of these helper functions. I already know the code, so I'm just gonna copy paste it here. So we have our wrapx and wrapy function. We also going to write our extend cells function. So as you can see here in the extend cells function, I am creating a new copy of the cells. And then I unshift the cells to add a new cell in front of the cells. So you can see here that in ReScript, you can use mutability or you can use immutability. Whatever is the most practical at the situation, you can use it. As you can see here, I am popping the array and I'm just ignoring the value, and I return the cells. Alright, so I forgot to put the board width and board height into the snake resi file. So this should be in. Now we just need to pass the board width and the board height in the snake.move here. And we have to pass the board.width and board.height. Okay, what's going on here? The record field width cannot be found. Okay, it is defined in another modular file. Bring it into scope by prefixing it with state module name. Okay, so we can just prefix it with the module name. This is a weird syntax, but it is what it is. Right, I cannot actually access the board.width because here we actually don't expose it. We just say that board has a type t, but we're not telling it whether it has the width or height. We do have function that get width and get height though, so we can use that. Alright, so we're done with the snake.move. Now we just have to code the functions snake.eatFood. Let's code the resi file. Snake.eatFood receives t and food.t. So this will return boolean. Let's code it. So I'm going to use array.findIndex up. So it tries to find the index of snake cells that satisfies this callback. And if it's found, if it's not found, then it will have none. If it's found, we don't care about the index and it will just return true. Cool, now we need to code the snake dot itself. Okay, so the code here will be a little bit cringy because some people will think it's hacky and full of mutation, but I'm going to show you that this is a feature because you can just use mutation whenever it makes sense, and most of the time you don't have to use it. So I'm going to use array reduce with index. I'm going to reduce over the snake.cells, and the initial condition should be false. And here is the callback. So the idea is I am going to iterate over other cells except this index and check whether the other cells actually intersect this cell or not. So I'm using option.getExtend here. It means that if this snake.cells is of type sum, then we're going to unwrap the value and have the value here. If it is of type none, then this option getExtend will actually throw an exception. But me, as a programmer that knows more than a compiler, I know that this cannot throw an exception at all. So it's okay to use it here. This while loop will keep looping until it finds another cell that intersects with this current cell. And when it finds it, we are going to do a Boolean operations here, which is OR, so that the end result will be true. Now we can see that something is happening here on the right. It looks very fast because request animation frame is running really fast, so we can actually slow it down a little bit. Let's go back to the game.res, and we are going to introduce a count. So the idea is if the count is lesser than some settings, we have count per update here. We're just going to update the count. But we don't do anything else, so don't do any rendering, don't do any game logic. But else, now we do the game logic. Now we are able to make our game slower. Alright, so we have our game, but we still cannot control the snake. Now let's code the controls code. We'll name it register control. We have the bindings.addEventListener, and we want to listen over key down, and it will receive an event. So we can just make a switch over event.which, and if it is left, then we do something here. Let's just name console log first. So now it's time to register it on the app.res. Let's do register control. Okay, let's see if we are able to register the controls. Yep. So if I press up, right, down, left, okay, we got it. And I actually want to change the state of the snake. So I'm going to pass the snake here. So we can have snake ref. And we're going to read the snake direction. And we're going to pattern match it here. So we're saying if we are pressing the key left and snake X direction is 0, we don't care about the Y direction, then we're going to turn left. And we'll do the same thing for up, right, down, and we don't care about the rest. Doesn't seem that this is working. This one is wrong. Should be snake.dy. Okay, so we verified that left and right is not working. I'm wondering why. Up and down is working. Yeah, right. That's because when we are on the x direction, obviously we cannot do left and right again. So that's why the left and right here doesn't register, because the dx is never 0. So let's just continue coding it. So I'm going to use snake set speed left. This should be set speed up, set speed right. Let's make a variable here. Looks like it's working. I got my control incorrect. I think it should be minus here. It should be positive here. Something is wrong with the food rendering here. But the snake logic is working. The food is not rendered correctly. Here it is. Alright, so let's see if this works. I forgot this. We have to multiply it by grid. Yes, because this is the pixel measurement that we have in our game. Alright, so I'm pretty sure this one will work. There you go. We finally have our snake game. So what do you think of the overall experience? I hope you learned something today, and I hope you didn't feel bored with my long-winded explanation. Thank you for watching, and I'll see you next time.